Good morning, students. Next concept of exercise 2.3. Now take reader page number 58. Some properties of complex numbers are given. Page number 58. The first property, closure property. For any two complex numbers z1 and z2, the sum z1 plus z2 is also a complex number. Closure property for addition. Closure property. For any two complex numbers z1 and z2, then z1 plus z2 also a complex number. Now let z1 is equal to x1 plus iy1 and z2 equal to x2 plus I into y2. z1 plus z2 equal to x1 plus iy1 plus x2 plus I y2. We know addition of complex numbers, real part adding with real part. So x1 real part and x2 real part. So that is equal to x1 plus x2. This is real part. Then imaginary part is what? iy1, iy2. So now taking I is common, y1 plus y2. So this implies, this is also the form of a plus ib or x plus iy. Because x1, x2, y1, y2 belongs to R. R is a set of all what? Real numbers. Therefore, z1 is a complex number, z2 is a complex number. Then z1 plus z2 is also a complex number. That is called closure property. z1 plus z2 is also a complex number. Next, similarly, closure property for multiplication. For any two complex numbers z1 and z2, the product z1 z2 is also a complex number. Same for product case. Closure property for addition, closure property for multiplication. z1 into z2. Similarly, take z1 x1 plus iy1 and x2 plus iy2. Product x1 plus I into y1 and x2 plus I into y2. Product of numbers x1, x2, x1, x2. Then x1 into I, y2. That is I into x1, y2 plus I, y1, x2. I, y1, x2. Next I into I square, y1, y2. We know that property of complex number I square equal to what? Minus 1. Therefore, x1, x2 plus I into x1, y2 plus I into y1, x2. I square is what? Minus 1. Therefore, y1, y2. Since note that I square equal to minus 1 using the property of complex number. So, two real part, x1, x2 real part minus y1, y2 real part. So, that is equal to x1, x2 minus y1, y2 plus I taking common from these two x1, y2 plus y1, x2. So, this is also form of x plus iy or now treating x plus iy or a plus ib form. So, product of two complex numbers is also a complex number. This is the properties of one of the property of complex number. Next, commutative property. Property number 2, page number 59. For any two complex number z1 and z2, z1 plus z2 equal to z2 plus z1. z1 plus z2 equal to what? z2 plus z1. And also the page number 59 property proof also given. z1 plus z2 equal to z2 plus z1. Right. Closure property. z1 plus z2 equal to z2 plus z1 Sulika. Addition is always what? Commutative. Addition is always what? Associative. 2 plus 3 equal to what? 5. 3 plus 2 equal to what? Similarly, it is true for complex number cases. Now take z1 plus z2 addition. That is already we know x1 plus x2. That is x1 plus iy1 z1 value, x2 plus iy2, x1 plus x2 plus I into y1 plus y2. Addition, this is addition. x1 plus x2 can be written as x2 plus x1. 2 plus 3, 2 plus 3, 3 plus 2. Both are what? Same. Similarly, I into y2 plus y1. y1 plus y2 also written as what? y2 plus y1. Next, x2 plus x1 plus I y2 plus I y1. Now the pairs x2 plus I y2 is the one of the pair. Then another pair x1 plus I into y1, second pair. So x2 plus I y2 equal to what? z2. This is what? z2. This is what? z1. But now you are taking z1 plus z2. that is equal to what? Z2 plus Z1. Z1 plus Z2 equal to Z2 plus Z1. That is commutative property for addition. And also page number 59, the property proof also given. Proof already reader la kuduthirukanga. Adha na inge proof panniten. Result mattum illa, proof ayum padichukonga. Puriyudungala? Next, it is also true for product Z1 Z2 commutative property. Z1 Z2 equal to Z2 Z1. Z1 Z2 equal to what? Z2 Z1. Z1 Z2 already we know Z2 Z1 Z2 inge nama pannirkom pathingala complex numbers. First type la nama pannirkom. First type la pathina just commutative property is also the product Z1 Z2 is also a complex number. Appdin prove pannirkom. In the property extension commutative property la nama use pandrom for any two complex numbers Z1 and Z2. For any two commutative means what? Taking two terms, compulsory two terms irukonu illaya commutative. AB equal to BA. Lower classes la neenga algebra la adha padichirupinga. Ipo nama padikka poradhu complex number. For any two complex numbers Z1 and Z2, Z1 into Z2 equal to Z2 into Z1. So Z1 into Z2 na inga already solve panni vechiruken. Indho irukku parunga Z1 into Z2 irukungala. So now treating this is equation number 1. Z1 Z2 case inga already irukku. Now inga just Z2 Z1 mattum solve pandrom parunga. Z2 Z1 Z2 x2 plus I y2 and x1 plus I y1. So that is equal to x2 x1 x2 into x1 plus I into x2 y1 plus I into y2 x1 I into I square y2 y1 I square. What is the value of I square? Minus 1. So in the rendu term நம்ம ப்ராடக்ட் பண்ணீங்கன்னா I y2 into I y1. தோ இங்க கொடுத்திருக்கேன் பாருங்க. இங்கெல்லாம் I square யூஸ் பண்ணிருக்கேன். நம்ம வந்து இனிமேல் I square லாம் யூஸ் பண்ண கூடாது. Now replacing I square equal to what? Minus 1. பேசிக்கா நம்ம வந்து இப்ப 2.3 எக்ஸர்சைஸ் போயிட்டோம். நான் ஃபர்ஸ்ட் எக்ஸர்சைஸ் செகண்ட் எக்ஸர்சைஸ்ல I square னு ட்ரீட் பண்ணேன். இனிமேல் மேக்ஸிமம் I square க்கு பதிலா டைரக்ட்டா -1 ட்ரீட் பண்ண ஆரம்பிச்சுவேன். நீங்க நல்லா கவனிங்க. I y2 I y1. So I into I square. I square value is what? -1 y2 y1. y2 y1. So what are the real parts? Two real part and two imaginary part. x2 x1 minus y2 y1. This is real plus I into x2 y1 plus y2 x1. Now treating this is equation number 2. Listen here, equation 1 x1 x2 x1 x2. Product is always what? Commutative because x1 belongs to R, x2 also belongs to R. x1 x2 equal to x1 x2 minus y1 y2 minus y1 y2 plus I into x1 y2 x1 y2 x2 x2 y1 x1 y2 x2 y1. So therefore from equation 1 and 2 these are what? Equal. Therefore product of two complex number is always commutative. That is Z1 into Z2 equal to Z2 into Z1. Next the associative property. Associative property means same page number 59. Now take three complex numbers. For any three complex numbers Z1, Z2, Z3 equal to associative of property. Z1 plus Z2 plus Z3 equal to Z1 plus Z2 plus Z3. For any two complex numbers Z1, Z2 and Z3, then we have Z1 plus Z2 plus Z3 equal to Z1 plus Z2 plus Z3. It is also satisfied. Next, it is also similarly for multiplication. Complex number multiplication, same page number 59, right side. The associative property for any three complex numbers, Z1, Z2 and Z3, Z1, Z2 into Z3 equal to Z1 into Z2 into Z3. Z1 into Z2 Z3. So இந்த ப்ராப்பர்ட்டிஸ் எல்லாம் உங்களுக்கு அப்ஜெக்டிவ்ல யூஸ் ஆகும், ப்ராப்ளம்ஸ்லயும் யூஸ் ஆகும். ப்ராப்பர்ட்டி வித் நேமோட நீங்க புரிஞ்சுக்கணும். புரியுதுங்களா? நெக்ஸ்ட் additive identity. This is an important one more question, subdivision number 4. Additive identity. There exists a complex number 0 equal to 0 plus I 0 such that for every complex number Z can be written as Z plus 0 equal to 0 plus Z equal to Z. Additive identity. Additive identity for addition is 0. Additive identity for addition is 0 in right side the multiplicative identity, there exists a complex number 1 is equal to 1 plus 0i, such that for every complex number z1 z dot multiplication dot 1 dot z equal to what? Z. That's all. So additive identity is 0. 0 can be written as 0 plus I0, because complex number means a plus ib or x plus ib form. So both real and imaginary. Totally real part also absent, imaginary part also absent. This can be written as 0. So z plus 0 equal to 0 plus z equal to z. Additive identity. Similarly, in multiplication, the additive multiplication with respect to is what? 1. Z dot 1 equal to 1 dot z equal to z. That's all. So 1, the page number 59 la subdivision 4 last line parunga, subdivision 4 rendu concept irukku. Additive identity, multiplicative identity la 0 plus 0i is known as additive identity. Underline பண்ணிக்கோங்க. 0 plus 0i is known as additive identity. Right side la parunga, 1 is equal to 1 can be written as 1 is equal to 1 plus 0i. That means real part 1, imaginary is what? Absent. That is 1 can be written as 1 plus 0i. This is a form of x plus iy or a plus ib form, is known as multiplicative identity. So இத வந்து கொஞ்சம் அண்டர்லைன் பண்ணி வச்சுக்கோங்க இந்த ரெண்டு ப்ராப்பர்ட்டி. அடுத்து நாம பார்க்க போறது additive inverse. Next நாம பார்க்க போறது additive inverse.